Welcome to the debate. Our topic today, well, it leaves Earth's surface entirely. We're focusing on what many see as the next great frontier, space mining. And look, this isn't just science fiction anymore. It's becoming an emerging economic and scientific reality. It promises access to potentially enormous resources currently locked away in places like the asteroid belt, everything from gold and platinum to crucial water ice. But here's the fundamental tension, the real debate. Should this huge, multi-billion-dollar effort be primarily driven by solving resource scarcity here on Earth, chasing high-value materials, or should the focus be on enabling cheaper, self-sustaining colonization out there?
Right, and that strategic tension is really the core of what the source material explores. We're essentially weighing the, astronomical potential value of precious metals, things destined for Earth's market, against the sheer strategic necessity of using resources in situ. That means, local processing, using what's there to build cheaper, lasting infrastructure in space. And so I'll be arguing today that the immediate direction, the justification, really has to be in situ resource utilization, ISRU, specifically focusing on things like water and common metals to actually enable expansion out there.
Okay, and I'll be taking the position that the primary and I'd argue necessary driver for this initial, frankly monumental investment, it has to be the vast economic return. Specifically, the return offered by high-value precious metals for the terrestrial market. Honestly, that's the only way an endeavor this expensive even gets funded in the first place. So let me lay out why the financial imperative is just enormous. Modern tech, right? Think high-efficiency catalytic converters, components in EVs, clean energy systems. They rely heavily on platinum group metals, PGMs, things like rhodium, palladium, and also rare earth elements. Now, mining these here on Earth is costly, it's destructive, and it's increasingly tangled up in geopolitical risks. We simply need a new source, and the potential yield from space extraction is, well, it's staggering. Some estimates suggest a single, maybe half-kilometer-wide platinum-rich asteroid could hold more value in PGMs than humanity has ever mined. Ever! This kind of potential wealth, this promise, is realistically the only catalyst strong enough to secure the billions, likely tens of billions, of private capital needed to develop the tech, fully autonomous mining robots, deep space transport. So the initial phase, it just has to focus on bringing purified, ultra-valuable material back to Earth or maybe lunar orbit to guarantee that return on investment.
See, I just don't buy that the immediate profit motive, especially tied solely to Earth, should define something this potentially transformative. Focusing entirely on earthbound returns for precious metals, I think it's actually dangerous, and certainly economically unstable. The source material itself flags this risk, the risk of crashing global commodity markets if you suddenly introduce, hundreds of tons of platinum. And this isn't just a short-term price shock we're talking about. It could trigger structural deflation, potentially making those very metals, almost worthless for decades because the supply just explodes. The enduring value here isn't rarity, it's utility in space. And that means focusing on resources that slash the massive logistical and financial burden of space activity itself. Think common metals, iron, nickel, cobalt for building things in space. And most critically, water. H2O. Water is, quite rightly, I think, being called the new oil of space. You can break it down into hydrogen, super efficient rocket fuel, and oxygen for life support. This enables essentially orbital gas stations, dramatically cutting the cost of every single subsequent mission beyond low Earth orbit. That's the real game changer.
Okay, I agree the funding hurdle is immense, and I absolutely appreciate the strategic long-term vision of, an independent space economy. That's compelling, but here's the problem. If we prioritize slow ISRU development, maybe focusing initially only on marginal returns from water or common materials, the advanced tech required, these fully autonomous robots operating in extreme conditions, millions of kilometers from any human help, it will never secure the initial necessary funding to even be developed. We are talking about investments of billions, maybe tens of billions up front, Platinum's high price, driven by scarcity here on Earth, is honestly the only economic lever we currently have that's strong enough to finance these multi-billion-dollar development missions today. If the project isn't commercially compelling right out of the gate, the technology simply won't materialize. It just won't happen.
But you're potentially solving an Earth problem by immediately creating a cosmic one and a geopolitical one. If this promise of instant astronomical wealth triggers a private sector gold rush, which seems likely, we immediately run headfirst into a serious legal conflict. I mean, you've got the 1967 Outer Space Treaty, which says nations can't claim celestial bodies. Okay. But it's dangerously vague, really silent on private extraction ownership. Then you have later things like the U.S. Space Act of 2015, which explicitly authorizes U.S. citizens to commercially recover space resources and keep property rights over them. So what happens if private companies start hauling back tons of platinum and saying, this is ours? That instantly becomes a geopolitical flashpoint. It risks international conflict and could undermine the entire technological leap before it even gets stable. Strategic self-sufficiency, using local processing and focusing on utility resources like water. It neatly avoids this whole claim and conquer narrative entirely. It's just cleaner.
I understand the regulatory ambiguity, I really do. But the risk of some future legal dispute, I think, is secondary to the immediate technological challenge of just starting. We need those high-value targets to justify the initial discovery and mapping phase. I mean, look at NASA's Psyche mission, right? It's entirely focused on studying a metal-rich asteroid, specifically looking for its composition, targeting high-density metals. It's not primarily looking for water ice. This type of mission, which helps us map and identify the really valuable resource bodies, is a necessary first step. And let's be honest, it's funded largely by the promise of PGM returns down the line, not the promise of slightly cheaper rocket fuel maybe years from now. ISRU is definitely the long-term goal, I concede that, but PGM demand is the short-term economic fuel that gets the engine started.
I think we need to look closer at what we mean by genuine, lasting value, though. Is it just market price driven by scarcity? Or is it utility? I'd argue the highest value is in utility, especially in space. We should prioritize the materials that directly serve space activity. If we can use local iron, nickel, or cobalt for construction, maybe 3D printing components for space stations or habitats right there, we avoid the absolutely staggering cost and inefficiency of launching heavy materials from Earth's deep gravity well. Anyone who follows the launch industry knows the potential savings here are, they're revolutionary. And this entire ecosystem, this entire vision, relies fundamentally on locally sourced water for propellant and life support. Without cheap, readily available water in space, the cost of sending every kilo of construction material, every human crew member, it just remains prohibitively high, regardless of how much platinum you might have hypothetically stockpiled back on Earth.
Look, we are already seeing the initial steps, right? Private companies are making attempts. And the next 2 decades, I believe, will see key breakthroughs in autonomy. The technological challenge is profound, no doubt. Operating these complex robots so far from any human maintenance, it's hard. But this complex, expensive technology will only be fully developed and crucially sustained if the target is those high-return materials needed for terrestrial demand. That's what guarantees the massive, immediate ROI that private stakeholders absolutely require.
That's a fair point regarding the private sector's motivations, I'll give you that. But I would argue that tethering this entire, potentially species-defining effort solely to Earth's fluctuating commodity markets and this perpetual need to address terrestrial scarcity, it just creates a fundamentally weak foundation. What happens if, say, after decades of investment, some breakthrough in materials science back on Earth suddenly eliminates the need for rhodium and catalytic converters, or some other PGM? Poof! The entire economic basis for the space mining venture potentially collapses overnight. Strategic self-sufficiency, however, using local water and common metals, that creates a far more robust and independent space economy, one that's detached from Earth's commodity volatility and is focused squarely on building a permanent human presence in space. That long-term vision, secured by utility, not just rarity, feels like the much less risky path ultimately.
Space mining is, I think we both agree, undoubtedly a major next step for human development. But I maintain that it absolutely must be driven, at least initially, by the compelling economic opportunity to solve Earth's resource needs through this astronomical wealth. The immediate promise of platinum, gold, other PGMs, that's the necessary force. The only force strong enough, really, to overcome the immense technological hurdles we face in these first couple of decades. It ensures the massive private investment that makes the whole thing even remotely possible.
And while that economic potential is certainly alluring, the risk of market disruption, geopolitical instability, and frankly, building on a potentially shaky foundation, it just seems too high to me. I believe the true and ultimately less destructive path forward lies in prioritizing those strategic in situ resources first, especially water and common metals. This approach, I think, provides the only viable long-term strategy for genuinely cheaper exploration and sustained human activity beyond Earth, while minimizing the economic and geopolitical chaos that chasing a high-value commodity rush seems almost inevitably poised to create.
Yeah. Ultimately, the future of space mining really does rest on this fundamental tension, doesn't it? Whether our cosmic ambition must be funded by first addressing immediate terrestrial scarcity, or if it can somehow survive and thrive purely on the strategic utility of its own self-made infrastructure out there. It's a tension, I suspect, that will shape the legal frameworks, the ethical debates, and certainly the technological investment for decades to come.